Class 66. So I'm super excited about this. Came home from work, and on the table there's a box sitting for me from Get FPV, and I'm like looking at the box thinking, what on earth did I order from Get FPV? Like, did I do it again? Like, did I have, so not that long ago, I was buying a bunch of parts and like, kind of looking at different sites and stuff like that. And I actually had forgotten that like one of the entire orders I placed, and shouldn't probably do that stuff late at night and like, but anyways, I was thinking, oh my gosh, did it happen again? And did I forget what I ordered? But no, it was these frames. So these are from C+. If you haven't followed along, you can kind of see some of the adventures of the early work on the RC group. So if you go in the 1S thread, C+ has been posting in there. And so he sent these along for me to try out, to test out a little bit, which is really kind of like, it's a pretty big honor that somebody has put this much work into something, and they're like, I trust my kind of judgment and skills to give kind of some early feedback on it. I don't expect these frames to perform as well as I think they will in the future, mainly because I was kind of pushing for, advocating of saying, hey, just release early and often and get some feedback. I didn't want to say too much early on because I wanted to see what C+, like, first you kind of want to let somebody get their, go down their own path, kind of have their own thoughts on something. But then at some point in time, there's diminishing returns of letting somebody just, kind of go on their own. And then you kind of get to that point where you start getting more returns by putting the thing out there, getting people's feedback, and being able to incorporate that and work from there. So these frames, I kind of wanted to like go over them and talk about some details first before I actually fly them, because I kind of want to test myself and challenge myself in terms of my understanding of things and some of my assumptions. And I thought that'd be kind of fun. So first of all, I think these frames are a little too light. So when I weighed them up before I built up this one, they were weighing in around 4.4, 4.6 grams. And I understand there's, I think, 3 different filaments. Well, actually, I think there's 2 different stock filaments. And I think a third filament, which is, I'm assuming this one probably here, is actually a combination, a custom blend, where C+ kind of took 2 filaments and did this like spiral print thing, and then made a new filament, and then used that to then print the frame, which is wild, to kind of like combine and get the different elements, different filaments that aren't available individually. So that was kind of wild. Some other neat like details to it, attention to details. I pulled this apart here, and of course, I think I lost the little TPU nub, and I'll have to find it. It jumped off there. So just little attention to detail. So these little rubber grommets, like the usual kind of like gummies that we used to mount our flight controller, these are really neat because inside the bottom part is wider to kind of fit over this little brass fitting, and then it kind of narrows up, and then the screw comes down. And it's just like, that was kind of like a really neat little attention to detail kind of thing that I wanted to point out. And there's a whole bunch of stuff that I think is really interesting here. But the big challenge, I think, early on is going to be getting these frames stiff enough. So these frames, if you kind of just take them in hand and you kind of start bending on them and you start twisting on them, they are okay, but I think they're a little bit lower than where they need to be. So the stiffness of these, I think, is kind of on par with where I used to cut frames at around 2 millimeter thick. And so this, I think this is a 2 millimeter thick, so this is a piglet frame. And so if I kind of bend this one and kind of twist it, this is probably still a touch stiffer than this frame here. And for the 120 size, so the 1S War Pigs, where I've kind of settled on is the 120 size frame and cutting them in 2.5 millimeter. So I think these frames are still a little bit softer than 2 millimeter, in the equivalent carbon fiber. So I think right there you just got to add a little bit more material or shaping to it to get the stiffness up. So the challenge, of course, like with these things is like flexibility is good in terms of crash survivability. So the longer your arm is, when you come in and crash, that gives more room to disperse the energy, it gives you more room to flex. And it makes it less likely that any one part of the arm is going to get to that critical point where it goes from, where it can't flex enough and it's just going to snap instead of flexing. And so the longer your arm is, the better it is going to do in terms of absorbing that. The problem is the longer the arm is, has the negative impact on being able to resist, flexing and twisting when it comes to motor noise. And so the longer and flexier your arm is, the higher the amplitude of the vibration and the oscillation, and also the lower the frequency. And lower frequency oscillation is harder to filter out than higher frequency. On the flip side, so I see that what C+ did is kind of put this ring here, where some of the earlier versions had, you can see that there's kind of this central kind of box bracing, and so kind of ice, like right in the middle of that box, that's going to be pretty nice and strong and stiff. And then the flight controller mounts kind of come off on this little star-shaped thing. But that leaves kind of some low-hanging fruit in terms of being able to brace this up a little bit further. So obviously you don't want anything under the prop line because you don't want anything disrupting the airflow. And so one of the early revisions, what I suggested, what kind of pointing some of this stuff out, I think C+ actually went and did the brace like that. So Chris Rosser uses those. So there's AOS frames. And the bracing, yeah, it's going to address that twisting. But the thing that it's going to do, it's also going to create a stress riser like right in the middle of your arm, because now you've got, if this is like, I don't know exactly what this is, but if this is 3 millimeters wide and you put a brace right there, and so then you effectively kind of double it, you're suddenly going from one thickness to a much thicker thing. And so that is going to have a very short span where when you crash, it's going to have a very short span where it can flex, and then you have stress risers, and I think make it more vulnerable to breaking. So pretty good compromise here with doing the ring style, I think. But still maybe could have brought this out instead of doing like a ring. Maybe, I understand for sure that like you kind of want things to have some sort of like style to it. Like it's got to have your personality, but there might be a little bit of you could potentially brace this maybe a little bit more aggressively than this ring without creating too much of a stress riser. The other thing too is like if you look at this ring, so this square right here is going to brace really well versus this ring I don't think is going to do quite as much. And so potentially if you just kind of move this all out to the ring, you might do better that way. This is kind of what I'm seeing and thinking. Now, otherwise, what are you going to do? How are you going to get this stiffness? So you can add probably a gram of material, I think, and that'd probably be fine. Your weight's still going to be fine. I think the other thing you need to do, there's a hint of it right here where you can see those middle of those arms are hollow. What you can do, so with carbon fiber, you got to think in like just a chunk, like a slab. You can't think like hollow structures versus here we can do like all kinds of different tubes and shapes. And so some of the advantage of that is to get stiffness now, you can actually make these arms a lot bigger in terms of volume and hollow out the middle, and you can get stiffness without generating more weight. Now that's probably going to some degree compromise some of your durability and crash survivability, but there's some definite options there. The other thing too is with carbon fiber, you have a limit of how thin you can go. If you go any thinner than like 1.5 or 1.75, you start losing structural integrity when you actually mill out the frame. So there's kind of this minimum thickness. And so if you think about that and you kind of want to do a brace across in carbon fiber, there's sort of a minimum thickness that you can do. And you're going to get like kind of a certain range of strength because like you're only going to be as thick as your frame is thick. So if this is like a 2 millimeter, that's only going to be 2 millimeters thick. On the other hand, when we're printing, yes, you still have fibers in there and you still want like kind of a minimum sort of total thickness, but in this case you can go super thin but really deep, and you can basically go from the motor mount to motor mount, and that way you're not going to create a stress riser, and yes, it's going to go under the prop line, but because you have it very thin but very deep, it's actually going to be very aerodynamically efficient. It's going to have a very low CDA, coefficient drag times area, and so it's not going to create a lot of disruption underneath the props. And so there's some other things there to think about that way too to get the stiffness up in terms of resisting the vibrations, things like that. So those are some of my initial thoughts. One other thought I had too is I think one of the ways that printed materials are really going to come into their own is when you start really integrating a lot of things. And so like one of the things is, since you're printing out this anyway, why not have like a little saddle for the battery to sit in? And then you can minimize how much you need in terms of other things like straps or whatnot to kind of like anchor it in place. But when I was kind of looking at these are a little bit, this one's flat. The other one was kind of bumped up here a little bit more, I think. And so the battery might not sit quite as well. But if you have a little saddle, you can kind of naturally start to use some of this integration. And I think some of that integration is really where some of the key is to getting this right. So first quad, I'm going to test this build. Just threw this on real quick. The reason for this is because I've got black box on this board. And yes, I know this is supposed to be a frame for 1S 3-inch, but I'm going to stress it a little bit. So I'm going to put it on, these props are going to generate a good amount of vibration, and this is going to be a 2S 2.5-inch. But that's going to give me a feel of where this frame is and how it resonates and where it needs to go from there. All right, so let's get these C+ frames up in the air and follow this up with another video to kind of talk about some early flight experience and go over some black box log. But I thought this was really interesting to start there. Oh, the other thing that came in the box, which is really interesting, is this right here. So this is that Darwin FPV board. It's a 1 to 3S 15 amp. And that right there is a little UFL connector for Express LRS. So that's I'm not sure if I knew about that. I'm not sure if I knew that Darwin FPV has an integrated Express LRS. I need to look up. I tried to look up quickly. I couldn't figure out whether it's SPI or via UART. I think it's probably going to be via SPI because it sounds like there's still 2 UARTs available, and with F411 you only got two to begin with. So if you're running Express LRS through a UART, you should only have 1 left. I think. I'm not sure, but I think that's how it works. So potentially there's going to be all the usual sort of problems with SPI running Express LRS and overloading the CPU. I've been working on specifically, I've been very interested in filtering without using RPM filtering, just using the dynamic notches, specifically to get a filtering strategy for these boards. They're using SPI Express or LRS because if we knock out the RPM filtering, we're going to take down the CPU load quite a bit and free up space to run the Express LRS via UART. So anyways, this is definitely going to be built up and tested out a whole bunch of different ways. So that's kind of interesting. So I'm excited about that too. All right. Until next time, cheers.